Good morning to all. Today our class is about periodic classification of elements. Introduction. There are 118 elements known at present and it is very difficult to study the properties of all these elements separately. Around the year 1800, only 30 elements were known. Scientists started working for some patterns in their properties on the basis of which they could study the elements with ease. Therefore, these elements are being classified into groups based on the similarities in their properties. So now we are going to study about Doberan's traits. In 1817, Johanna Wolfgang Dobryner, a German chemist, suggested a method of grouping elements based on the relative atomic masses. He arranged the elements into groups containing 3 elements each. He called these groups as triads. Tri meaning is 3. According to Dobryner, when the 3 elements in triad are arranged in the ascending order of their atomic masses, the atomic mass of the middle elements is nearly the same as the average of atomic masses of other 2 elements. This statement is called the Dobryner laws of triads. So next we are going to study about the limitations of this model. Now we are going to see about the limitations. There are instances of 2 elements being fitted into the same slot, example cobalt and nickel. Some elements today dissimilar in their properties were fitted into the same group. Arrangement of cobalt, nickel, palladium, platinum and iron in the row of halogens. The law of actives was not valid for elements that had atomic masses Limitations. Dobryner could identify only 3 triads from the elements known at that time, and all elements could not be classified in the form of triads. The law was not applicable to elements having very low and very high. Some elements, totally dissimilar in their properties, were fitted into the same group. Arrangements of cobalt, nickel, palladium, platinum, and iron in the row of halogens. The law of actives was not valid for elements that had an atomic mass higher than that of calcium. Newton's table was restricted to only 56 elements and did not leave any room for new elements. Discovery of inert gases, neon, argon, at later stage made the 9th element similar to the first one. Example, neon between fluorine and sodium. In 1869, now we are going to see about the Mendeleev's periodic table. In 1869, Russian chemist Dmitry Mendeleev observed that the elements of similar properties repeat at regular intervals when the elements are arranged in the order of their atomic masses. Based on this, he proposed a law of periodicity which states that the physical and chemical properties of the elements are the periodic functions of their atomic masses. He arranged 56 elements known at that time according to his law of periodicity. Next, we are going to see about the features of Mendeleev's periodic table. It has 8 vertical columns called groups and 7 horizontal rows called period. Each group has 2 subgroups A and B. All the elements appearing in the group were found to have similar properties. For the first time, elements were systematically classified so that similar elements were placed together. It was noticed that some elements could not be placed in their proper groups due to incorrect atomic masses. For example, the atomic mass of beryllium was revised from 14 to 9 and assigned beryllium a proper place. Mendeleev left blank spaces for unknown elements and predicted their properties. He named these elements EKA, aluminium, and EK silicon, which were later identified as gallium and germanium. Now we are going to see the limitations of Mendeleev's model. Elements with large difference in properties were included in the same group. Example, hard metals like copper and silver were included along with some metals like sodium and potassium. No proper position could be given to the element hydrogen. Non-metallic hydrogen was placed among with metals like lithium, sodium and potassium. The increasing order of atomic mass was not strictly followed throughout. Example: cobalt, nickel, tellurium, and iron. No place for isotopes in the periodic table. Now we are going to see about modern periodic table. In 1913, Henry Moseley showed that atomic number of element is a more fundamental property than its atomic mass. Mendeleev's periodic table was modified and atomic mass was adopted the basis of modern periodic table. Modern periodic table states that properties of elements are periodic function of their atomic number. The prediction of properties of elements could be made with more precision when elements were arranged on the basis of increasing atomic number. The modern periodic table helped overcome the three limitations of Mendeleev's periodic table. Now we are going to see trends in the modern periodic table. First, we are going to see about the valency. It is determined by number of valence electron present in the outer shell of its atom. Variation of valence in a period. On moving from left to right in each short period, the valence of elements increases from 1 to 4 and decreases to 0. Variation of valence in a group. Since the number of valence electrons of all elements in the group is same, all elements in a group have same valency. Now we are going to see about the atomic mass. It refers to the radius of an atom. Variation in a period. On moving left to right, the size of atoms decreases. Variation in a group. On going down, the size of atoms increases. Now we are going to see about the modern periodic table. In the modern periodic table, the zigzag line separates the metal from non-metals, metalloids. The borderline elements like B, Si, Ge, As, Sb, Te, and Pu exhibits properties of both metals and non-metals. And metals. They are found on the left side of the periodic table. Variation in a period. On moving left to right, the metallic character of elements decreases. Variation in group. On moving down, the metallic character of elements increases. Now we are going to see about the non-metals. They are found on the right side of the periodic table. Variation in the table. On moving left to right, the non-metallic character increases. Variation in group. On moving down, the non-metallic character of elements decreases. So finally, we are going to see what are the points to be remembered. Daubner grouped the elements based on the relative atomic mass in a group of 3 triads. John Newlands arranged 56 known elements in the increasing order of their atomic mass. Dmitry Mendeleev proposed the law of periodicity. Mendeleev's periodic table has 8 vertical columns called groups and 7 horizontal rows called period. In the modern period table, all the elements are arranged in the increasing order of their atomic mass. The elements are present in the period based on the number of shells in the atoms. Based on the common characteristics of elements in each group, they are grouped as various families. Thank you.